Metaphors, idioms, and affordances. Metaphors, idioms, and affordances. When the first edition of this book was published, interface designers often spoke of finding the right visual and behavioral metaphors on which to base their interface designs. As a result, designers created interfaces resembling office filled with desks, file cabinets, telephones, and address books, or pads of paper, or a street with signs and buildings. With the advent of Android, Windows Phone, and iOS 7, we have officially passed into a post-metaphorical era of interaction design. Modern device user interfaces and increasingly desktop UIs as well are properly content and data centric, minimizing the cognitive footprint of UI controls almost to a fault. One of the most fantastic things about digital products is that the working model presented to users need not be bounded by the limitations of physics or the inherent clumsiness of mechanical systems and 3D world of objects mapped to the control surfaces. So because we've moved from mechanical to digital, which we've discussed in the previous video about exercise as well, we don't need to rely with metaphors as well, unless with some certain and special case, which we were gonna discuss later. There aren't enough good metaphors to go around. They don't scale well, and the user's ability to recognize them is often questionable, especially across cultural boundaries. Metaphors, especially physical and spatial metaphors, have limited space in the design of most digital products. Interface paradigms. The three dominant paradigms in the conceptual and visual design of a user interfaces are implementation-centric, metaphoric, and idiomatic. The implementation-centric interfaces are based on understanding how things actually work under the hood, a difficult proposition. A metaphoric interfaces are based on intuiting how things work, a risky method. Idiomatic interfaces, however, are based on learning how to accomplish things, a natural human process. Historically, field of interaction design has progressed from a heavy focus on technology implementation to an equally heavy focus on metaphor, and most recently to a more idiomatic focus. Although many examples of all three types of interface paradigms still are in use today, the most modern information-centric interface design in common use on computers, phones, tablets, and other devices are primarily idiomatic in nature. So, the field of interaction design progressed from heavy focus to implementation and equally focus on metaphor, and most recently to a more idiomatic focus. So all the many examples of all three types of interface paradigms still are in use today. The most modern information-centric interface design in common use on computers, phones, tablets, and other devices are primarily idiomatic in nature. Implementation-centric interfaces. There is one button per function and one dialog per module of code, and the commands and processes precisely echo the internal data structures and algorithms. So again, there is one button per function and one dialog per module of code, and the commands and processes precisely echo the internal data structures and algorithms. The side effect of this is that we must first learn how the software works. internally to successfully understand the use of the interface. Clearly, implementation-centric interfaces are the easiest to build. Every time a developer writes a function, he slaps on a bit of user interface to test that function. It's easy to debug, and when something doesn't behave properly, it's easy to troubleshoot. Furthermore, engineers like to know how things work, so the implementation-centric paradigm is very satisfying to them. Engineers prefer to see the virtual gears and levers and valves because these help them understand what is going on inside the machine. So the idiomatic interfaces are partly the reason why the applications are so complex today, because the implementation in the back end are hidden in the front end. Before, it's easy because you just need to see it as it is a function in the front end, and it's easy to debug. But those artifacts needlessly complicate things for users. Engineers may want to understand the inner workings, but most users don't have either the time or desire. They'd much rather be successful than knowledgeable, a preference that is often hard for engineers to understand. So, design principle, most people would rather be successful than knowledgeable. A close relative of the implementation-centric interface worth mentioning is the org chart centric interface. This is a common situation in which a product or most typically a website is not organized according to how users are likely to think about information. Instead, it is organized by which part of the company or organization owns whatever piece of information the user is looking to access. So it is organized which depending on the part of the company on that piece of information is looking to access. Such a site typically has a tab or area for each corporate division, and there is a lack of cohesion between these areas. So it's not organized based on users' mental model. It's organized based on the organization by way of their accessing the information. Such a site typically has a tab or area for each corporate division, and there is a lack of cohesion between these areas. Similar to the implementation-centric product interface, an org chart-centric website requires users to understand how a corporation is structured so that they can find the information they are interested in. Metaphoric interfaces. Metaphoric interfaces rely on the real-world connections users make between the visual cues in an interface and its functions. Since there was less of a need to learn the mechanics of the software, metaphoric interfaces were a step forward from implementation-centric interfaces. Metaphors can range from tiny icons on toolbars, buttons, to the entire screen on some application. From a tiny pair of scissors on a button indicating cut to a full-size check box in Quicken. So it relates on how people see the real world. Since there was less of a need to learn the mechanics of the software, metaphoric interface were a step forward. So it's better than the implementation-centric interfaces. It can range from tiny icons on toolbar buttons to the entire screen on some application. From a tiny pair of scissors on a button indicating cut to a full-size checkbox in Quicken. Instinct, intuition, and learning. In the computer industry, and particularly in the user interface design community, the word intuitive is often used to mean easy to use or easy to understand. Based on Merriam-Webster, intuition is the power or faculty of attaining to direct knowledge or cognition without evident rational thought and inference in. Uh, in reality, no magical quality of intuitiveness makes things easy to use. Instead, there are concrete reasons why people grasp some interfaces and not others. So, when a child encounters an angry dog, she instinctively knows that bared teeth signal danger, even without any previous learning. Instinct is hardwired response that involves no conscious thought. So it's a hardwired response with no conscious thought or without evident rational thought and inference. Example of instincts in human computer interaction include how we are started by unexpected changes in the image on our computer screen, how we find our eyes drawn to a flashing advertisement on a web page, and how we react to sudden noises from our computer or the haptic vibrations of our video game controller. Intuition, unlike instinct, works by inference, in which we see connections between disparate subjects and learn from these similarities while not being distracted by their differences. So it's about recognizing the difference on things. Also, our mind constantly try to learn the patterns of things without actually knowing what it really is by means or by way of just recognizing the similarities. We grasp the meaning of metaphoric elements of an interface because we mentally connect them with other things we have previously learned in the world. So, in order to make sense of it, you intuit how to use a basket icon, for example, because you once learned how a real waste basket works, thereby preparing your mind to make connection years later. You didn't intuit how to use original waste basket. It was just an easy thing to learn because it was new. So you learn this waste basket icon. It's the same thing with idiom as well, as we will discuss. Uh, Metaphorical interfaces are an efficient way to take advantage of the awesome power of the human mind to make inferences. However, this approach also depends on the idiosyncratic minds of users, which may not have the requisite language, learning experience, or inferential power necessary to make those connections. So, sometimes you don't have enough vocabulary to make the metaphor or the cultural heritage or the requisite language, learn experiences that helps you inference that to thing that you want to learn. So metaphorical interfaces may not be as easy as to learn as idiom, which we will later see. So intuition or intuitive uh, could be used in learning at a certain for especially for 3D or 2D interface such as this GUI could be used to learn in certain circumstances, but most of the time it's not, so as we will later see. The tyranny of the global metaphor. So an extreme example of using the metaphor in the wrong way is Magic Cup, the operating system for a handheld communicator. You access your messages from an inbox or a notebook on a desk. So just like you access it in the real world or in the knowledge work before. You walk virtually down a hallway lined with doors representing secondary functions. So you walk out the hallway to represent the secondary functions that you could do. You went outside to access third-party services, which is shown in figure 13.1. So this is how it works in the real world, and the software wants to mimic it. Figure 13.1 were represented by buildings on a street. You enter the building to configure a service, and so on. So here, the Magic Cup interface from General Magic. Relying heavily on metaphor such as this means that you can intuit the software's basic functions. But the downside is that after you understand its function, the metaphor adds significantly to the overhead of navigation. So this is the downside of Intuit, using Intuit in learning, because you learn this now because you have learned that before, but after you become an intermediate user, it become an overhead in navigation. A significant overhead. You must go back out onto the street to configure another service instead of having that in one screen. You must go down the hallway into the game room to play solitaire. So Alexander Graham Bell would have been ecstatic if he could have created a phone that let you call your friends just by pointing to pictures of them. So pointing up pictures to them and then calling, just like what we do today. He couldn't do so because he was restricted by the dreary realities of electrical circuits and bakelite moldings. So design principle: never bend your interface to fit a metaphor. Other limitations of metaphors: large desktop file icons as a means of accessing and manipulating files were a good idea when computers had floppy drives or 20 MB hard drives with only a couple of hundred files. But in these days of terabyte hard drives and tens of thousands of files, file icons become too clumsy to use effectively by themselves as a means for moving files around. So a file icons becomes too clumsy by if you use especially a big icons to move files around. Instead, you use Control C and Control V. Next, while it may be easy to discover visual metaphors for physical objects like printers and documents, it can be difficult or impossible to find metaphors for processes, relationship, services, and transformations, the most frequent use of software. So it may be easy to discover visual metaphors for physical objects like printers and documents. It is hard or difficult to find a metaphor for digital objects, because usually the objects that we want to find metaphor, if we're still gonna use metaphor, are processes, relationships. So processes, these are functions. Relationships, which is the properties. Services, and transformations. So kind of all related to classes and object-oriented programming, the most frequent uses of software. It can be daunting to find a useful visual metaphor for changing channels, purchasing an item, finding a reference, setting a format, changing photographs resolution, or performing statistical analysis. Yet these operations are the type of processes we use software to perform most frequently. Yet these are the things, the processes like purchasing an item, finding a reference, setting a format, that we perform frequently. Metaphors also rely on associations perceived in similar ways by both the designer and the user. So if the user doesn't have the same cultural background as the designer, metaphors can fail. Even the same or similar cultures, significant misunderstandings can occur. Does a picture of an airplane in an airplane app mean check flight arrival information or make reservation? So that could be confused. Exceptions to the rule. So here, for some app such as this instrument, it could be done, but it is just in special cases. So Sunriser is an iPad synthesizer that closely resemble its hardware brethren. On a touchscreen, simulated knobs and sliders make sense if your users are accustomed to hardware user interfaces, since the interaction with them is so similar to the real-world interactions. However, the creators of Sunrisers have not become slaves of the global metaphor in the physical world, but rather adopted the uh, power and strengths of digital or computing on the real world as only digital interface can. Swiping left or right on the keyboard slides higher or lower octave keys into view. So swiping left or right provide a higher or lower octave keys, effectively removing the limitations of this screen width. So as people increasingly make use of multi-touch displays in place of hardware control gadgets, tools, and instruments, it's reasonable to expect that real-world metaphors will eventually fade and be supplanted by idiomatic interfaces more optimized to expressive gestures. So since another reason is that while we don't use the manipulation of physical objects as printing, and we use the manipulation of objects such as processes, is that it will fade because other more expressive gestures available for 2D or graphical user interface will prevail. So it will be the same with the virtual reality as well, or VR gadgets. So we're gonna use a more expressive things that could be done better there. So TZ11 takes a completely different approach to creating an expressive digital instrument. It sports a unique, abstract, and completely idiomatic user interface in which the user must learn by exploring the tonal and visual effects created by touching and gesturing. It even includes a sophisticated patch editor for building new sounds and interactions. Idiomatic interface. So this is the idiom that I was talking about since the beginning of the videos. Uh, mm, Idiomatic user interfaces solve the problems of the previous two interface types by focusing not on technical knowledge or intuition of function, but on learned mental models to achieve their goals and tasks. So it's learned mental models. It's actually the mental model that we are talking about to achieve their goals and tasks, which we've discussed in the previous video. Idiomatic design, what Ted Nelson has called the design of principles, is based on how we learn and use idioms, figures of speech like beat around the bush and cool. We understand the idiom simply because we have learned it once and because it is distinctive, not because it makes subliminal connections in our minds and we do so without realizing it. So this is the answer for intuition, intuit, intuition, into what's that, and learning and and instinct. So these are the answer for that. Intuition is this distinct behavior that becomes our mental model. Later we will discuss the instinct part in how we learn by using affordance. So we understand idioms if we have learned it and because it is distinctive, not because it makes subliminal connection in our minds. And we do so without realizing it. If you cannot intuit an idiom, neither can you reason it out. Our language is filled with idioms that if you haven't been taught them makes no sense. So if you cannot intuit it, and you can't also reason it. If someone says Uncle Joe kicked the bucket, you know what he means even though no bucket or kicking is involved. You can figure it out by thinking through the various permutations of smuggling pills with your feet. Or you can think that based on the function or what it actually works under the hood or in physical objects, because it's kind of like distinctive. And you can learn the meaning of this expression only from context in something you read or by being explicitly taught it. So you learn it by context on which specific thing that distinctive behavior applied. So because so this distinct, kind of like in news, it always repel to our consciousness because it's new. So whenever something is new or distinctive, we always remember it. You remember this obscure connection between buckets, kicking, and dying only because humans are good at remembering things like this. Graphical interfaces are largely idiomatic. Windows, title bars, close boxes, splitters, title bars here. This is the title bars, close boxes here, X, splitters here, hyperlinks, so that's the website, and drop downs here. Are things we learn idiomatically rather than intuit metaphorically. So instead of that learn metaphorically, it's that intuit is learned idiomatically. OS X use of a trash can to unmount an external firewire disk before removing it is purely idiomatic, and many designers consider it a poor idiom, despite the visual metaphor of the trash can. So the unmount of OS X is purely idiomatic despite having a visual metaphor of the trash can. So as soon as you slide the mouse around on your desktop, you see a visual symbol, the cursor, move around on the computer screen in the same way. Move the mouse left and the cursor moves left. Move the mouse forward and the cursor moves up. As you first use the mouse, you immediately get the sensation that the mouse and cursor are connected. So these idiomatic intuit are learned through context, but at the same time through our visual and hearing senses, and sometimes touch. This sensation is extremely easy to learn and equally hard to forget. That is idiomatic learning. Modern multi-touch user interfaces seen on most smartphones and tablets also are idiomatic. Also, although touching objects on the screen to activate them is intuitive, we can intuit that because we're directly manipulating the object. So the gestural idioms must all be learned. So this is the difference between intuit and intuitive. Here, we intuit the idiom instinct rather. Yeah, we intuit the idiom using the learned behavior. Here, um, the modern multi-touch interface, the gestural idioms for that must all be learned. So touch gestures, when designed correctly, can be learned even more easily than mouse movements. This is because you have more direct ability to manipulate objects on screen with your fingers rather than via virtual proxy of a mouse cursor. So it uses more of our senses, our sense of touch. Ironically, many of the and also it has a full screen gesture, right? So ironically, many of the familiar graphical UI elements that have been historically thought of as a metaphoric are actually idiomatic. So many of these familiar graphical UI elements that we use today are actually idiomatic. Artifacts like resizable windows and endlessly nested file folders are not really metaphoric because they have no parallel in real world. They derive their strengths only from their easy idiomatic learnability. So since it's just idiomatic kind of like learn once and it's distinct, we learn them easily. But we have to learn it. We have to be intermediate. Good idioms must be learned only once. So most of what we know, we learn without understanding things like faces, social interactions, attitudes, melodies, brand names, the arrangement of rooms and furniture in our house and office. We don't understand why someone's face is composed the way it is. But we know that face, we recognize it because we have looked at it and have automatically and easily memorized it. So this is what I'm saying earlier. It is quite easy to learn idioms like neat or politically correct, or the lights are on but nobody's home, or in a pickle, or take the eye, or grunge, or fragile, or panel, or all in, etc. The human mind can pick up idioms like this from a single hearing. It is similarly easy to learn idioms like radio buttons, close boxes, drop down menus, and combo boxes. Mhm. So here, the radio buttons, close boxes here, drop down menus, and then combo boxes are easy to learn. So design principle, all idioms must be learned. Good idioms need to be learned only once. Branding and idioms, marketing and advertising professionals understand well the idea of taking a simple action or symbol and imbuing it with meaning. After all, synthesizing idioms is the essence of product branding. So we can also build an idiom, and it's also used in marketing a lot. And also, we've discussed in the previous video the concept of attribute, in which we use that one attribute to accompany our product context or goal, in which a company takes a product or company name and imbues it with desired meaning. So figure 13.4, this idiomatic symbol has been imbued with meaning from its use rather than by connection to other objects. So it doesn't connect in real world or other objects. So for anyone who grew up in the 1950s and 1960s, this otherwise meaningless symbol has the power to evoke fear because it represents nuclear radiation. Visual idioms such as the American flag can be just as powerful as metaphors, if not more so. So this could be as more powerful than actually metaphors. So the Aristotle concept that metaphor is the highest form of thinking may not be applicable in GUI. So the power comes from how we use them and what we associate with them, rather than from any innate connection to real world objects. Building idioms. The first graphical UI, such as the original Mac OS, were better primarily because the graphical nature of their interfaces required a restriction of the range of vocabulary by which the user interacted with them. So the first GUI for macOS are better because of the limited input that you can apply. In particular, the input they could accept from the user went from an unrestricted command lines to a tightly restricted set of mouse-based actions. In a command line interface, users can enter any combination of characters in the language, a virtually infinite number. So since you have a infinite input, it's harder to use a command line. It's harder to remember the keys. For a user's entry to be correct, he needs to know exactly what the application expects. He must remember the letters and symbols with exacting precision. The sequence can be important. Sometimes even capitalization matters. In modern desktop UIs, users can point to images or words on the screen with the mouse cursor. Most of these choices migrated from the user's heads to the screen. So all of those command line was translated from user's head or the computer's knowledge to the screen, eliminating any need to memorize them. Using the mouse buttons, users can click, double click, or click and drag. The keyboard is used for data entry and typically not for command entry or navigation. So the keyboard is not for command or invoking function or for navigating inside the application, but mainly for data entry, for the repetitive or keys that we just need to manually put in text. The number of atomic elements in users' input vocabulary has dropped from dozens to just 3. This is true even though the range of tasks that can be performed by modern software apps isn't any more restricted than that of a command line systems, though there is an exception, but it's very rare that you see that you can do something in GUI that you can do something in GUI that you can do in command line, because most of this has been translated in graphical objects. So because of those complex combination of 2D and 3D, the more atomic elements in an interaction vocabulary has, the more time consuming and difficult the learning process is. Restricting the number of elements in our interaction vocabulary reduces its expressiveness at atomic level. However, more complex interactions can easily be built from the atomic ones. Much like letters can be combined to form words and words to form sentences. So since it's infinite, the issue now is how the developer would combine these complex commands in the backend that could be created in a visual object manner. But because of the system or applications that have been built, such as even AI was created to, or ChatGPT was created to create this multiple easy to learn GUI, it still begs the question of you could potentially create this complex objects or command line interface and navigation with a few simple GUI combination. So, and add to the fact that most of the things that user needs to create a or to do on their goals or to achieve their goals is just 1 to 3 functions. So this created more productive um, things, and it helps the user a lot, which help us prosper as a whole. So here, the more atomic elements interaction vocabulary has, the more time consuming and difficult the learning process is. So the more the command line is, the more difficult the learning process. And also that could also hinder you from just achieving your goal with a few functions. Restricting the number of elements in our interaction vocabulary reduces its expressiveness at the atomic level. However, more complex interactions can easily be built from the atomic ones, much like letters can be combined to form words and words to form sentence. So we actually use the power of that combination of words to sentence, but now into an idiom. So here, in modern desktop graphical UIs, this primitive consists of pointing the mouse, clicking and tapping a key on the keyboard. In touch gesture system, they consist tapping and dragging. So that's our primitives: point, click, drag, key presses. Invisible actions and feedback mechanisms. Cursor text. And then the middle layer contains compounds. These are the more complex constructs created by combining one or more of the primitives. They include simple visual objects such as text display, actions such as double clicking, dragging, swiping, and pitching, and manipulate objects like buttons, checkboxes in a form, links, and resize handles. Idioms, which is the idioms that we've learned, combine and structure compounds. So it's much like this is words, and these are sentence, and then these are paragraphs. So these things allow us to uh, do paragraphs at the same time, kind of like the selection control. We've discussed how combination of control allow us to uh, create different or multiple commands to the noun, and then describe the noun and the verb at the same time. So it allows us to create complex object properties or commands at the same time. Idioms combine and structure compounds using domain knowledge of the problem under consideration. So because this app allows us to use these idioms, we need to have a domain knowledge. So the consequences of using these paragraphs based objects is that we need to have this domain knowledge to be able to successfully apply this idiom, because we're structuring compounds or multiple sentence. That's why the user needs to be an intermediate, but once they learn that, they will never forget that if it's a good idioms. Or if it's the way to have a good idiom is to have that idiom related to their goals and their mental models, and make sure that it is not disrupting them from their task. So information related to the user's work patterns and goals, not specifically to the computerized solution. So it's about their context. So because it's domain related on that part of the screen, when you click that, it will produce that paragraph, and then it will help them achieve their goal. They don't need to remember this complex commands to use it. So the set of idioms opens the vocabulary to information about the particular problem the application is trying to address. In a graphical UI, it includes things like labeled buttons and fields. So the set of idioms opens the vocabulary to information about the particular problem the application is trying to address. That's why those deep domain knowledge that application are designed to do are not are actually form this initiate this immediate paragraph and sometimes book in just one idiom. In a graphical UI, it includes things like labeled buttons and fields. So labeled buttons that has tooltip and fields. Those things are actually this combination of paragraphs and books. Navigation bars, list boxes, icons, and even groups of fields and controls or entire panes and dialogues. It depends on the context that's what you want to use. So that what makes it complicated now. So that's why it's really hard to understand how these things works from the back end to the front end. So any language that does not follow this form will be very hard to learn. Many effective communication systems outside the computer will use similar vocabularies. Street signs in the US follow a simple pattern of shapes and colors. Yellow triangles are cautionary, red octagons are imperatives, and green rectangles are informative. So the reason for that is because it is idioms that could be more powerful than metaphors. So it allows to differentiate things in context to learn that easily because it's so distinctive. So this is the heart of any language that is easy to learn. Manual affordances. So this we will gonna tackle the what's this instinct part of the learning. So manual affordances. So from here we tackle the learning by intuition. So here we were gonna tackle learning by instinct. So we combine that in this GUI, which makes us able to achieve domain level expertise in each of our application because those applications are specialized. Now, Donald Norman give us the term affordance, which he defined as the perceived and actual properties of the thing, primarily those fundamental properties that determine just how the thing could possibly be used. But so it's a perceived and actual properties, primarily those fundamental properties that determine just how the thing could possibly be used. So that's the affordance, is how the thing could be used. But we propose altering Norman's definition by omitting the phrase and actual. So here, as you can see, primarily the perceived and actual properties of the thing, primarily those fundamental that determine just how the things could possibly be used, or an actual. So when we do this, affordance become a purely cognitive concept. Referring to what we think the object can do rather than what it actually do, because this what we think can do could actually be applied in a 2D interfaces, because we cannot really see that in the real world, it doesn't actually act like that in the real world, just like a metaphor. So if a push button is placed next to the front door of a residence, its affordance are 100% doorbell. If when we push it, it causes a trap door to open and we fall into it, it turns out that it wasn't a doorbell, but that doesn't change its affordance as one. So because those button makes you think that you could manipulate or use it. So how do we know it's a doorbell? Because we have learned about doorbells, door etiquette, and push buttons from our complex and lengthy socialization process. We have learned about this clash of pushable objects by being exposed to electrical and electronic devices in our environs, and because years ago we stood on doorstep with our parents learning how to approach another person's home. So because of the setup of the environments, we learn those things. So as you can see, this is how the mystical aspect of this, because all of those things that we see in that real world and experience kind of become affordance to us, but we don't know why those things actually structure the way that is, right? Why that doorbell is like that when it could be another type, right? It could be another shapes, right? So that's where we could go to space now, right? So manual affordance is when artifacts are clearly shaped to fit our hands or body. We recognize that they can be manipulated directly and require no written instructions, like when a push button in an unlikely place, such as the hood of a car. We cannot imagine what its purpose is, but we do recognize it is a pushable object. We recognize this because of our tool manipulating instincts. So we have that innate tool manipulating instinct. So that's where the instinct part of learning. Norman discusses at length how manual affordance are much more compelling than written instructions. So instead of written instructions, which is the best way to learn, such as reading those instructions, or best way to convey these complex topics. But Norman discussed how manual affordance are much more compelling to make it easy to learn. For example, a door that must be pushed open using a metal bar for a handle. The bar is just the right shape and height and is in the right position to be grasped by the human hand. The door's manual affordance scream, "Pull me!" No matter how often someone uses this diabolic door, he will always attempt to pull it open, because the affordance are strong enough to drown out any number of signs affixed to the door saying push. The design of widgets for older operating system interfaces like Windows 7 and OS X relied, relied on shading, highlighting, and shadows to make screen images appear more dimensional. So the widgets for older operating system actually use highlighting and shadows to make it more 3D, more dimensional, or more real. These are so-called skeuomorphic clues have fallen out of fashion with Android KitKat, Windows 8, and OS Mavericks. But where they appear, they offer virtual manual affordances in the form of button-like image that say push me or slide me to our tool manipulating brains. So it actually triggers that makes it easy to learn. However, recent trends in flattened visual minimal user interfaces threaten ease of use by removing this virtual manual affordance in the service of visual visual simplification. Semantics of manual affordance. Unlike mechanical objects, you can figure out a virtual lever's functions just by tracing its connection to other mechanisms. Software can be casually inspected in this manner because they are in GUI. Instead, we must rely on either supplementary text and images, or most often our previous learning and experience. Instead, we must rely on text and images, or sometimes audio and a previous learning, because that's how we learn. The Windows 7 scroll bar affordance clearly shows that it can be manipulated, but the only things about it that tells us what it does are the arrows frequently missing in mobile apps, which hint at its directionality. So arrows frequently missing in mobile, which hints its directionality. So the scroll bar arrow are the only thing that hints us of this directionality. So it's also activate our instinctual learning instead of relying on more cognitive demanding task. So to know that a scroll bar controls our position in a document, we either have to be taught or learned through experimentation. So controls must have text or iconic labels on them to make sense. So it has a text first for us to become an intermediate. Kind of like in reading, you need to really read first before you become 28 years old for men, because it will allows you to easily understand those controls instinctively in the future, or based on the books that you have read. If the answer isn't suggested by the control, we can only learn what it does by one of two methods: experimentation or training. So if it doesn't have text, kind of like in real life in books, right? The only way for you, if you don't read that and then learn from the mistake of others, you will have to force to learn that by experimentation or training or in experiences. We either read about it somewhere, ask someone, or try it and see what happens. We get no help from our instinct or intuition. We can only rely on the empirical. So fulfilling expectations of affordance, that's also the importance of reading books early. Uh, Fulfilling expectations of affordance in the real world, an object does what it does as a result of its physical form and its connection with other physical objects. So, to fulfill the expectation of affordance, so in the real world, an object only does what it does as a result of its physical form and its connection with other physical objects, because otherwise we would be shocked and we could like, for example, if something is on fire and the physical objects doesn't show like that, you won't notice it and you won't avoid it. So it's just natural. Also can cut wood because its serrations are sharp, its blade is flat, and it has handle. A knob can open a door because it is connected to a latch. However, in the digital world, an object does what it does because a developer imbued it with the power to do something. We can discover a great deal about how a saw or a knob works by physical connection, and we can easily be fooled by what we see. On a computer screen, though, we can see a raised three-dimensional rectangle that clearly wants to be pushed like a button, but this doesn't necessarily mean that it should be pushed. We can be fooled because there's no natural connection as there in the real world between what we see on the screen and what lies behind it. So it's really depend on how the developer imbued the interaction that relate to the user mental model. A lot of applications offer bait and switch manual affordance. Uh, uh, sorry. Offer bait and switch manual affordance. This is relatively rare for push buttons, but is all too common for other controls, especially on websites, where the lack of affordance can make it difficult to differentiate between controls, content, and ornamentation. So, a lot of controls, such as this instinctive behavior push button, makes it website hard to use. Make sure that your application delivers on the expectation it's set via the use of manual affordances. So make sure that if that provide that hint that it could be push, it really could be push. So be cautious, especially for a website. It's most common mistake. So direct manipulation and pliancy. Modern graphical user interfaces are founded on the concept of direct manipulation of graphical objects on the screens. Buttons, sliders, menus, and other function controls, as well as icons and other representations of data objects. So, modern GUI form from the concept of direct manipulation, which is of a graphical objects on screen, like buttons, sliders, menus, and other function controls. So, like what we've discussed in the videos, different function controls could provide different paragraphs, or different, could be book, like a combo box, as well as icons and other representations of data objects. So the ability to select and modify objects on the screen is fundamental to the interfaces we design today. In 1974, Ben Schneiderman coined the term direct manipulation to describe an interface design strategy consisting of three important components: visual representation of the data objects that an application is concerned with. So on that domain-specific application, the visual representation of data objects in its database, visible and gestural mechanisms. So gestural mechanisms, like in learn gestural behavior, like in the mobile phones, for acting on these objects, as opposed to free-form text commands. So that limited input that allows us to combine these paragraphs in just learn idioms and to do this behavior. Immediately visible results of these actions, so immediate feedbacks on the data in the database. So those form direct manipulations. It might be more accurate to call it visual manipulation, because the importance of what users see during the process because of the feedback. Virtual manual affordances and rich visual feedback are both key elements in the design. Visual feedback are both key elements in the design of direct manipulation interfaces. So these affordances are actually at the same time satisfies the rich visual feedback of that our instincting that capitalize on our instinct of this affordance, that help us learn things quickly in context, in combination with the idiom learned, provides a powerful way to create paragraphs, books in domain-specific applications. So here, design principle, rich visual feedback is the key to successful direct manipulations. Uses of direct manipulation. Using direct manipulation, we can point to what we want. If we want to move an object from A to B, we click or tap it and drag it there. As a general rule, the better, more flow-inducing interface are those with plentiful and sophisticated direct manipulation idioms. So we can just point on the object on the screen and then click or tap based on a learned behavior. So a better, more flow-inducing interface are those with plentiful and sophisticated direct manipulation idioms. So this provide a flow, which we're gonna discuss in the next video. That A more sophisticated direct manipulation idioms, because it allows us to be so productive, create paragraphs and books in just those simple steps. For example, most word processors let you set tabs and indentations by dragging a marker on a ruler. Someone can say, in effect, here is where I want the paragraph to start. So the application then calculates that this is precisely 1.347 inches from the left margin, instead of forcing the user to enter 1.347 in some text box somewhere. So instead of this multiple commands that could have been done in command line interfaces, such as programming this, the application calculates this 1.347 and then provide an input box, etc. You just need to click that paragraph. Here is where I want the paragraph to start. And also, instead of like saying that manually, you just click that. That's provides less cognitive load. So Google Snap Speed Photo Editor for iPad uses gestural control. So this is for iPad to position and manipulate visual effects parameters via tapping, pinching. So tapping, pinching, twirling, and swiping. Numeric feedback is provided in addition to real-time previewing. So a numeric feedback allows us to see that just like in intuition or rich motion instinctual brain, it taps on our instinctual brain that allows us to see what is the exact number. But into textual numeric feedback is provided in addition to real-time previewing, but no textual numerical entry is required, or in fact even allowed, not that it is missed. So the principle of direct manipulation applies in a variety of situations. When items in a list need to be reordered, the user may want them reordered alphabetically, but he may also want them in order of personal preference, something no algorithm can offer. So sometimes the user could want to reorder the objects based on personal preference instead of alphabetically. So if you want to conduct or use an algorithm of that in the back end and use an implementation model, it will be hard because no algorithm can offer that. So a user should be able to drag the items into the desired order directly without an algorithm interfering with these fundamental operations. So that's where the magic comes. Drag and drop can also save the user from tiresome and repetitive use of dialogues and menus. So this drag and drop are simple idioms that allow us to create paragraphs. Also avoid these dialogues and menus that before consisted of how we manipulate objects in the backend. So these are the previous learned idioms. So in the Sonos desktop controller shown in figure 13.7, users can drag songs directly to any location in the current play queue, or instead drag them to any speaker in the house for immediate feedback. So they don't have to open a menu and choose options. So the Sonos desktop controller lets you drag songs and albums from search and browse result to anywhere in the playback queue. To the now playing area for immediate playback, or to any room in the house. So that could be hard to be done algorithmically. So you just need to set up this and then you're gonna learn new things that could be done in the front end. So you do so with a single drag and drop gesture. So tablet versions of the app also allow similar direct manipulation of music. You seldom see direct manipulation interfaces for entering complex numeric data, because that's just not how the direct manipulation are designed. If you want a complex numeric data, you could use a command line interface. Usually, you're given numeric entry fields or sliders. A great example of direct manipulation of graphically represented numeric data is the Addicting Sync app for the iPad, shown in figure 13.8. So Addicting Sync is an iPad music synthesizers that allow users to draw their own waveforms and audio effects curves with their fingers and then hear the results in real time. There's a reason for the app's name. The experience is immersive and satisfying. Direct manipulation is simple, straightforward, easy to use, and easy to remember. However, as we have discussed, direct manipulation idioms, like most other idioms, must first be learned. Luckily, because the visible and direct nature of these interactions bears a close resemblance to interactions with objects in the physical world, learning the idioms usually is easy. After you learn them, you seldom forget them. Direct So because of the visible and direct nature of these interactions bears close resemblance on how we manipulate objects in the real world, after you learn them, you seldom forget them, even if it's just not so good idiom. So direct manipulation isn't always appropriate. Direct manipulation, first persona system have their drawbacks. Although they are often used, fun and entertaining, it's often difficult to do really good job with them. They require the user to do the task directly, and the user may not be very good at it. So whom should we believe? So sometimes Don Norman, some like proponent of this, though it is fun and entertaining to use, the user needs to learn it. So they require the domain knowledge, and the user may not be very good. So whom should we believe? Is it ChatGPT? So direct manipulation is a powerful tool, but it can require skill development for users to become effective at complex tasks, such as designing an airplane using a CAD system. Many direct manipulation idioms, even relatively mundane ones, require motor coordination and a sense of purpose, which is achieved using those application-directed or goal-directed design. For example, even moving files between folders in Windows Explorer can be a complicated task requiring dexterity and foresight. Some amount of direct manipulation is usually a good thing, but depending on your persona skills and usage context, so sometimes based on your personas or and usage, it's also possible to go overboard on these idioms because they may not learn this or that use that function at all. As we learned in the previous video, not all functions are used. You should always consider what your personas need to manipulate manually and what the application can assist them with. So what the daemonic application can do with them, as long as they understand that domain-specific purpose of your app, either via guides and hints or automatically. Pliancy and hinting. We use the term pliant to refer to objects or screen areas that react to input and that the user can manipulate. For example, a button control is pliant because it can be pushed by a finger or a mouse cursor. So a pliant provides the instinctual brain that it is pushable. So a button is commonly the example for that. Any object that can be dragged is pliant. And every cell in a spreadsheet and every character in a word processor document is pliant. So any object on that graphical user interface is pliant. For spreadsheet, every cell is preant, every character in a word is preant. The only situation where this isn't true is when you are concerned with presenting rich, complex functionalities solely to expert users with no concern about their ability to learn and use the application, such as the command line interface. In these cases, the screen real estate and visual attention that would otherwise be devoted to communicating pliancy may be more appropriately used elsewhere. So the visual interface that occupies that real estate could be used elsewhere if they can use this command line base. So design principle, visually communicate pliancy whenever possible. So there are three basic ways to communicate or hint at the pliancy of an object to users. Create a static visual affordance as a part of the object itself. Dynamically change the object's visual affordance in reactions to change in input. So you change that when the mouse hover or other system events. So you provide the state when it is hovered. In the case of desktop pointer driven interface, change the cursor's visual affordance as it passes over and interacts with the objects. So creating this static visual affordance as part of the object is like making the object 3D that has dimension that allows them to signifies a physical or like a button. So dynamically change the state when you hover the mouse on the object. So sometimes you can change the cursor visual affordance, or you can change the cursor itself. For example, here when I can click on this space, the letters like letter I, as it passes over, interacts with the object. So this object or space is I can also manipulate using this I because the cursor changed. So static hinting. Static hinting is when object's pliancy is communicated by the static rendering of the object itself. So static hinting is when an object's pliancy is communicated by the static rendering. For example, a three-dimensional sculpting of a button control. So here is a static visual hinting because it provides virtual manual affordance for pushing. So it's like a 3D dimension that I've explained. For example, desktop interfaces with a lot of objects and controls. Static object hinting can sometimes require an impractical number of rendered screen elements. So these are actually occupies a lot of screen real estate. If everything has a three-dimensional field to provide affordance, your interface can start to look like a sculpture garden. Static hinting is well suited for mobile user interfaces. That's why it shifts from this simple graphical interfaces. But actually, they actually made it simple. But actually, that is, they use drawer now for visual hinting, and then they use 2D instead of this 3-dimension for a simpler. But it also cost them this visual affordance. Typically, fewer objects are on the screen at any given time, and they must by necessity be large enough to manipulate with fingers, leaving ample room for the necessary visual cues for affordance. Ironically, the current trend in mobile UIs is toward flattening and visually simplifying elements to the point where text, flat, monochrome icons, and rectilinear flat buttons and cards are the only visual elements available. This creates many challenges for designers, both from a standpoint of creating visual hierarchy and for indicating pliancy and affordance. So because of this move to that, it create a problem with to the designer, both from standpoint of creating visual hierarchy that allows you to emphasize it through 3D, and for indicating pliancy and affordance. So because that is where the most integrated in terms of technical design, you have to make do of what you have. Dynamic hinting, it works like this. When cursor passes over a pliant object, the object, so like this, the eye, temporarily changes its appearance as shown in figure 13.8 because the state change. The action occurs before any mouse buttons are clicked and is triggered by cursor fly over only. So these are triggered only by cursor fly over. So these actions are triggered only by cursor fly over. It is commonly called a rollover because it's triggered by cursor fly over. A good example of this is the behavior of icon buttons. See chapter 21 on toolbars. So we've discussed it in the previous video. Although it has no persistent button like affordance, passing the cursor over any single icon button causes the affordance to appear. Although it has no persistent button like affordance, so there is no like persistent affordance that shows that it is clickable. If you passed over any single icon, it causes the affordance to offer. So this is good for saving screen real estate and for desktop. The result is a powerful hint that the control has the behavior of a button, and eliminating the persistent affordance dramatically reduces the visual clutter on the toolbar. So the buttons on the left are an example of static visual hinting. Their clickability is suggested by the dimensional rendering. The toolbar icon buttons on the right demonstrate dynamic visual hinting, while the bold toggle doesn't appear to be button at first glance. Passing the mouse cursor over it causes it to change, thereby creating affordance. Alas, touchscreen devices have no real equivalent to dynamic object hinting. Designers and users must make do with whatever static hinting at pliancy is available to them, because you cannot do the dynamic hinting in touchscreen. Pliant response hinting. Desktop pliant response hinting should occur if the mouse cursor is clicked but not released, or while a finger is pressed on a control. So the state won't change if it's not released. The control must so the pliant response hinting should occur if the mouse cursor is clicked but not released. So these are programmed, this pliant response are programmed to occur if the mouse is clicked but not released, or while the finger is pressed on a control. The reason, the control must know that it is poised to undergo a state change. More on this previous video. This action is important and is often neglected by developers who create their own controls. A push button needs to change from a visually raised state to visually indented state. A checkbox should highlight its box but not show a check just yet. Pliant response is an important feedback mechanism for any control that either invokes an action or change its state. It lets the user know that some action is forthcoming if she releases mouse button. So those are clue that it will change the state if you release the function. Therefore, allowing a pliant or instinctive understanding that allows you to do complex tasks. Pliant response is also important part of the cancel mechanism. When the user clicks a button, that button responds by becoming indented. If the user, when a user clicks a button, that button responds by becoming indented. If the user moves the mouse or his finger away from the button while still holding it down, the on-screen button returns to its quiescent raised state. So it will be indented if you click that, but if you move the or hover the mouse, it will go back to its raised state. It will not be indented, which is the push state. If the user then releases the mouse button or lifts his finger, the on-screen button is not activated, consistent with the lack of pliant response. So if there's no rich modeless feedback, it means that it doesn't the change of the state was not successful. So it's very effective in helping us learn this intuitively instead of using command line. So we're allowed to make this complex domain specific action. Cursor hinting communicates pliancy by changing the cursor's appearance as it appears over an object or screen area. For example, when the cursor passes over a Windows frame, the cursor change to headed arrow, showing the double-headed arrow, showing that it could be here. I think I should here the double-headed arrow, showing the axis in which the window edge can be stretched, which shows indication that it can be stretched only if you hover your mouse there. This is the only visual affordance indicating that the frame can be stretched. Generally speaking, controls should offer static or dynamic visual hinting. So generally speaking, for controls that we've discussed in the previous, they should offer static or dynamic visual hinting that hint their instinctiveness. So whereas pliant, manipulable data more frequently should offer cursor hinting. So this static or dynamic in which that button or icon show a hint on themselves, whereas things that could manipulate data should offer cursor hinting, such as this window. This data window could be changed using the cursor like this, up and down arrow, because we have learned that it could stretch the window and the extra. So for example, it is difficult to make dense tabular data visually hint at pliancy without disturbing its clear representation. So sometimes a lot of data, especially for continuous data and even in the discontinuous data, this pliancy that provided by static or dynamic visual hinting is actually distracting, and it disturbs its clear representation, especially for data-driven or domain complex applications. So cursor hinting is the most effective method. Some controls are small and difficult for users to spot as readily as button, and cursor hinting is vital for the success of such controls. So some controls that are small are hard to spot, like the printing for Word. So the column dividers and screen splitters in Microsoft Excel, column dividers or the screen splitters right here, like this, it only shows when you hover, are good examples. So here, Excel uses cursor hinting to highlight several controls that are obviously pliant by themselves. You can set column width and row height. So Excel uses cursor hinting to highlight several controls. So this highlights several controls that are, so here adjust, select, when you hit, I think when you hit control, it will show that. So Excel uses cursor hinting to highlight several controls that are not obviously pliant by themselves. You can set column width and row height by dragging the short vertical lines between each pair of columns or rows. The cursor changes to A two-headed horizontal arrow that both hints at the pliancy and indicates the permissible drag direction. The same is true for the screen splitter controls. When the mouse is over an unselected editable cell, it shows the plus cursor, and when it is over a selected cell, it shows the drag cursor. Again, touchscreen users and designers are out of luck with using this kind of pliancy hinting. So for this cursor or dynamic hinting, cursor hinting, the touchscreen is not applicable, as we'll discuss in that we've discussed in the previous video. Other strategies must be employed in the design of touchscreen apps to ensure the users know what objects they can manipulate, when they can do, and what actions and gestures are supported, like drawers, etc. Escape or the cards. Escape the grip of metaphor. Reserve global visual metaphors for those few special contexts where the metaphor is truly an integral part of the experience. Don't use metaphors as a crutch to support rapid learnability or short-term comfort. Instead, create memorable and appropriate idioms that make your users more effective and efficient. So that are imbued with rich. So these idioms or that we have learned make your users more effective and efficient are imbued with rich pliant feedback, and that allow users to focus on the context and the domain and functionality of your app rather than the confines of outmoded mechanical age metaphors and interactions. You'll be doing them a favor as they become intermediate users, and you ultimately hope they will be for them to use your app. So here, orchestration and flow. Orchestration and flow. If our goal is to make the people who use our products more productive, effective, and engaging, we must ensure that users remain in the right frame of mind. This chapter discusses kind of mental ergonomics. So if we want our user to be intermediate and then use our product more productively, which is their goals, usually their end goals based on the persona, it describes how we can ensure that our products support user intelligence and effectiveness. So it will support their mental model and their cognitive, based on their cognitive capabilities and effectiveness. It also covers how we can avoid disrupting the state of productive concentration that we want our users to be able to maintain. So we will discuss the flow now, which is the focus. Muscle. Flow and transparency. When people concentrate wholeheartedly on an activity, they lose awareness of peripheral problems and distractions. The state is called flow. So they lose the peripheral problems and distraction, like the eye or visual concentration. Concept first defined by Mihaly in Flow. The Psychology of Optimal Experience, 2008. In Peopleware, Productive Projects and Teams in by Tom DeMarco and Timothy describe flow as condition of deep, nearly meditative involvement. Flow often induces a gentle sense of euphoria and can make you unaware of the passage of time. So because you lose that peripheral problems and distractions. Most significantly, a person in state of flow can be extremely productive, especially when engaged in constructive activities such as engineering, design, development, or writing. To state the obvious, then, to make people more productive and happy, it behooves us to design an interactive products to promote and enhance flow. So it's in our best interest to design a harmonious application that activates or triggers this flow for them, for us to better help them achieve their goals. So remember, like, achieving their goals are highly interconnected to their visceral or their visual, because or the way they sense things because the way they sense things is actually the best or their most cognitively demanding senses. So we need to remove a lot of excise or most excise, which we will discuss later. Most significantly, a person in state of flow can be extremely productive. Sorry. In most cases, if the user could achieve his goal magically without your product, he would. By the same token, if the user needs the product but could achieve his goals without messing about with the user interface or visceral, goal, he would. Interacting with productivity software seldom is an entirely aesthetic experience. So, though it could be beautiful that your software providers pliancy, it's still best to do it with less, because if they can achieve it with this without messing about with the user interface, he would. So entertainment and creative tools aside, interacting with software, especially business software, is very much a pragmatic exercise. So no matter design principle, no matter how cool your interface is, less of it would be better. A user interface is an artifact, not directly associated with the user goals. So it's just it created task. So it's like in a developer's mindset, like the best code is no code. Next time you find yourself crowning about a cool interaction you've designed, remember that the ultimate user interface uh, can often be no interface. When a novelist writes well, the writer's craft becomes invisible, and the reader sees the story and characters with clarity, undisturbed by the writer's technique. So the novelist's goal is to immerse the person in the story to eventually help them escape the reality. Because if that could be done without a novel, that person would. So that's the reason why the person is writing a novel. Likewise, when a product interacts well with the person, interaction mechanics disappear, leaving the person face to face with his objectives, unaware of the intervening software. Just as a poor writer is a visible writer, a poor interaction designer looms with a clumsy visible presence in his software because it's distracting. It could be done in your the way in you done socially. If your profile picture in Facebook is not related to the context though of the people's goals of or what they try to achieve, it will be useless because it just distract their goal. Again, design principle is no matter how good your face is, less of it would be better if they could achieve it themselves. So just a poor writer is visible writer because you see the writer type, how the writer type. Also, it's also best to use an idiom when typing so that people could be helped by your writing instead of them not noticing your writing. So you should not use like any unusual phrases or make sure that you don't disrupt their context. So it's all about context orchestration. To a novelist, there is no such thing as good sentence in isolation from the story being told. No rules govern how sentences should be constructed to be transparent. So there's no good sentence in isolation on the story because all perform in one context. It all depends on what the protagonist is doing or what the effect the author wants to create. The writer knows not to insert an obscured word in a particularly quiet and sensitive passage, lest it sound like a sore note in a string quartet and it will distract the user in the main context and then the main goal or the user experience that it wants to achieve, which is to immerse the user. The same goes for software. The interaction designer must train himself to hear sore notes in the orchestration of software interaction. So it's being a good designer is actually being a good writer because it allows you to train yourself to hear source notes in the orchestration of software interaction. It is vital that all elements in an interface work together coherently toward a single goal. When an application's communication with a persona is well orchestrated, it almost becomes invisible. So almost invisible. You want to become invisible if you've done the software right, or if you're done the writing right, or the context right, or what you want to achieve with less exercise. Webster defines orchestration as harmonious organization, a reasonable praise for what we should expect from interactive products. So it defines orchestration as harmony, or like a chemist, that provides this harmonious organization in different parts. A reasonable phrase for what we should expect from interactive products. So interactive products should be harmoniously organized. Harmonious organization doesn't yield to fixed rules. You can create guidelines like 4 buttons on a thumb-driven mobile menu is good. So harmony could not be could not be created from a guideline, because it all depends on your user goals and context. And 6 buttons on a thumb-driven mobile menu is too many. Yet it is easy to see that a thumb-driven menu with 35 buttons wouldn't work. Though we don't have a guideline like that, like a 6 buttons applied to this context based on user goals and environment. It's easy to know that less is more. The 35 buttons wouldn't work. Because of our facts that our capability to remember is only from 7 plus or minus 2, or rule of 3 or 4. The major difficulty with such analysis is that it treats the problem in vitro. It doesn't take into account the problem for being solved. It doesn't take into account what a person is doing at the time, or what he is trying to accomplish. So it doesn't take to account the complexity of the world in each case of different person in different time, and which is often how developers are judged in preparing to those edge cases. So it treats the problem in vitro rather than context-based problem. It doesn't take into the account the problem being solved. It doesn't take into account what a person is doing, where he or she came from, what are their strengths and weaknesses, what time he is doing that, the state of economy, what he is trying to accomplish. Harmonious interactions. Although no universal rules define harmonious interaction, just as no universal rules define our harmonious interval in music, we've found the following strategies to be effective for designing interactions that go with the user's flow. So there's no rules that define, or there because like in the previous book, the framework are different for different contexts. We found the following strategies to be effective for designing interaction that go with the user flows. Follow users' mental models, kind of like following their world. What's their uniqueness, their characteristics that we got from goal-oriented design. So this is one of the principles that we could be based our harmonious flow that will help achieve the user end goal. Different people have different mental models of a given activity or process, but they rarely imagine them in terms of the detailed mechanics of how computers function. So they really model their way based on computer's action, because not all are computer literate. And each have a different models of a given activity or process. Each user naturally forms a mental image of how the software performs its task. Because like we've found in the what I've said earlier, the mind looks for these idioms, looks for some patterns of cause and effect to gain insight into the machine's behavior, because that's how we think, the past, present, and future. For example, in a hospital information system, the physicians and nurses have mental model of patient information that derives from how they think about patterns and treatment. So they have a mental model of patient information that will be based how they treat the patient. It therefore makes sense, more sense, to find patient information by using patient names as an index. So it makes sense to create an application that find the patient information by using patient name as an index. So each physician has certain patients. So it makes additional sense to filter the patients in the clinical interface so that each physician can choose from a list of his or her own patients organized alphabetically by name. So since each physician, based on that mental model, has a certain patient, it makes additional sense to filter the patients in the clinical interface, uh, organized alphabetically by name, so it's easy to find. So we're trying to reduce the navigational overhead that allows the physician to do immediately what they need to do, right? Kind of like providing this magic that could not be otherwise possible in the real world. On the other hand, in the hospital's business office, the clerks there are worried about overdue bills. They don't initially think about these bills in terms of who or what the bill is for, but rather in terms of how late the bill is and perhaps how big it is. So again, you're emphasizing on most important tasks or information related to that context. Thus, the application suited for that, or that big business offers interface, it makes sense to sort first by time overdue and perhaps by amount due, with the patient names as secondary organizational principle. Less is more. For many things, more is better. In the world of interaction design, the contrary is usually true. We should constantly strive to reduce the number of elements in user interfaces without reducing the capabilities of the products we are creating and without increasing the effort it takes to use them. So we need to reduce the elements in the interface without reducing the capabilities of the products to achieve the user goal. We must coordinate and control the product's power without letting the interface become a gaggle of screens and widgets covered with cluttering or unrelated and rarely used controls, because it just adds to their cognitive load. It is common for user interfaces of professional and business software to be complex but not very powerful. So that could be complex. So again, being complex does not equal powerful or really achieving our goal. It depends on the context. Also, being complex is not the same as difficult. Because difficult really is removing the unneeded controls. When the first edition of this book was published in 1995, the problem was ubiquitous. Something as common as save as dialog in a Windows application failed to allow users to also rename or delete the files they were looking at. So the save as dialog did not allow them to rename the files or delete it. Since it's a related function in the save as, you should also be able to delete other files on that menu, such as this. Let's try. So save as copy. I don't have, but for Word, I think we could do that. Save as. So here we can also delete this function. Let's see. So we were able to delete the files because it has this. I don't know if you're seeing that, but when I click the save as dialog of Word, it allow me to delete files on my file using File Explorer, because the File Explorer was integrated in downloads as well. I can delete a so I was able to delete. So let's see the recycle bin if it was deleted. Desktop or this PC. So I'm sure I was able to delete that, but that's just an example. So I can also rename that and that to allow me to faster navigate it. So that's the latest functionality of this interfaces today. So the users had to go to a different place to accomplish the very similar task or related task, ultimately requiring applications and operating systems to provide more interface, such as that dialog interface. Thankfully, contemporary operating systems are much better at this sort of thing because they have started to offer appropriate functionality based on the user's context. So it's not cluttered anymore with unnecessary dialogue. Users are less often required to shuffle off to various places and disrupt this flow and interface to accomplish simple and common tasks. However, we rather have long way to go. In the enterprise software we see today, a lot of things in their interface are still the kind of like the dialogue that's very complex and not powerful, such as Salesforce or etc. Each function or feature is often housed in a separate dialog or window, with little consideration for how people must use this function together to accomplish something. It is not uncommon for a user to use one menu command to open a window to find a bit of information, copy that information to the clipboard, and then use a different menu command for a different window, merely to paste that bit of information into the field. If you could provide that in the one window or one function, or one that could be learned in one idiom, much better. Not only this procedure inelegant and crude, but it's also error prone and fails to capitalize on a productive division of labor between humans and machines. So not only that, it's not we're not good at that because it's error prone. It fails to capitalize on our creative capability to create these paragraphs in the more complex and powerful way. Typically, products don't end up this way on purpose. They have been built either in an ad hoc manner over years or by several disconnected teams in different organizational silos. So this is called like technical debt and UX debt. So it's a combination of that. So it's also this disconnected teams in different organization that works in silo. Motorola's phone address book used a different text entry interface than its calendar application. So it's the same phone, but it's has a complex. First, it's already a complex input, but it has a different text interface for the same in the same calendar application within Motorola. Each software team must have devised a separate solution, resulting in two interfaces doing the job that one should have done. This was both a waste of development resources and a source of confusion and friction for Motorola's users. A year after the V3 reached the height of its popularity, the iPhone with its modern well-considered user interface arrived, and the V3 and all their flip phone brethren were soon history. Tight integration of the complete hardware and software experience finally won the day. So that instead of implementation model, they consider the user. So the iPhone won its the battle because of the software inside an interactive products is typically complex. It becomes all the more important to value elegance in simplicity. So because usually the software that runs on this hardware is complex, right? Because you have to code that and you need to debug that in implementation model way. These attributes are crucial for technology to effectively serve human needs, the simplicity and elegance. So look at Google. A minimalist approach to product design is inextricably tied to a clear understanding of purpose, what the user of a product is trying to accomplish using the tool. So it's that domain-specific application knowledge that allows us to go deep and allow us to serve the people using the products more. So without this sense of purpose, interactive products are just disorganized jumble of technological capabilities with infinite capabilities, just like a command line interface. That's why we're still not sure why if ChatGPT will conquer the market, because it still requires domain-specific understanding of people of that unlimited combination possibility in command line interface. So a model example where a strong sense of purpose about the tool has a driven minimal user interface is the classic Google search interface shown in figure 11.11. It consists of a text field, two buttons, Google search, which takes the user to a list result, and I'm feeling lucky, which takes the user directly to the top result. So it consists of a text field. So here, a long text field, two buttons, Google search, which takes the user to a list of results, and I'm feeling lucky, and which takes the user directly to the top. So I'm feeling lucky, it allows the user to go to the top result. So the Google logotype and a couple of links to the broader universe of Google functionality. So the Google logotype that allows, and a couple of links, so there's a links there that point to the broader universe or functionality of Google search engine. Another good example of a minimal user interface is the iPad Shuffle. By carefully defining an appropriate set of features to meet a specific set of user needs, Apple created a highly usable product with one switch and 5 buttons. So just one switch, and so they think carefully about the most useful features to meet the specific user needs with a minimal user interface and no screen. So still another example is IA Writer, an incredibly simple iOS text editor app. It doesn't have much of a user interface other than an area in which to write text. So the text is saved automatically, eliminating the need to interact with the files. When you type it, it automatically saves. So if you come from the world of CD players or even the high resolution screen of most other digital audio players, so if you came from high resolution screens of most CD before, it probably feels a bit weird to use the iPad's play or pause toggle to shut off the device and the menu button to turn it on, because you came from CD. This is a classic case of visual simplicity leading to cognitive complexity, because it didn't follow the user mental model. In this situation, these idioms are simple enough to learn easily, though it is provide that initial cognitive complexity. But since these idioms are simple enough to learn easily, the consequences of getting it wrong are fairly small. So the consequences of getting that wrong is small. So the product's overall success hasn't been affected much. So stick to less is more. Keep out your users' way and keeping them in flow. Let users direct rather than discuss. So when a carpenter hits a nail, he doesn't discuss the nail with the hammer. He directs the hammer onto the nail. In a car, the driver gives the car direction when he wants to change the car's behavior. The driver expects direct feedback from the car and its environment in terms of appropriate to the device. The view out of the windshield. The readings on the various gauges on the dashboard, the sound of rushing air and tires on pavement, and the feel of a lateral forces and vibration from the road gives the user a sense of feedback. So the carpenter expects similar feedback. The feel of the nail sinking, the sound of a steel striking the steel, and the shifting weight as the hammer recoils. The driver certainly doesn't expect the car to interrogate him with a dialogue box, nor would the carpenter appreciate the dialogue shown in this. Don't provide this because the user are directing it. So it needs to feel the winds. Don't distract it the flow, right? So let them direct rather than discuss. So rather than asking for the input of the customer for a dialogue and otherwise asking for a cognitive load for a simple task, let them control it. So provide choices rather than ask questions. Dialogue boxes, confirmation dialogues in particular, ask questions. Toolbar and Palace offer choices. So dialogues, it asks question to input a modal dialog box, otherwise it won't go back to the main screen. Toolbars and Palace, on the other hand, are always there, quietly and politely, offering their ways like a well-appointed store, giving you the luxury of selecting what you want with just a flick of your finger. Choices are important, but there's a difference between being free to make choices based on presented information and being interrogated by the application in the modal fashion. Users would much rather direct their software the way they direct their automobiles down the street. Keep necessary tools close at hand. Most desktop applications are too complex for one mode of interaction to cover other features. So since you're creating paragraphs and books, these applications are too dense and domain specific for only one mode of interface to cover all the features. Consequently, many applications offer users a play of tools. These tools are actually different modes of behavior that the product enters. So those tools, the controls that we've discussed in the previous video, are actually different mode of behaviors that we manipulate using our mouse and keyboard, and the different learned idioms, and it could create these complex paragraphs and books or complex like functions. Offering tools is a compromise with complexity. So if you operate those different mode, it could provide complexity, though you could offer more functionality. But we can still do a lot to make a tool selection and manipulation easy and to prevent it from disturbing flow. So we can still use this palette to avoid the flow. Let's say these complex tools or tasks are needed in this related task. We can provide a tool palette. Mainly, we must ensure that information about tools and application state is clear and presented, that transition between tools are quick and simple. So the transition, the effect, like it allows a rich modeless feedback, and the instinct behavior and the idiom all combined allows us to make this complex in this one specific domain of application that provides us a complex and sophisticated task with less effort. Now, tools should be close at hand, commonly on palace or toolbars, for beginner and intermediate users, and accessible by keyboard command for expert users. So, tools are commonly on palace or toolbars for beginner and intermediate, and it should be closed, and keyboard shortcut for expert users. This way, the user can see them easily and can select them with a single click or keystroke. If the user must divert his attention from the application to search out a tool, his concentration will be broken. It's as if he had to get up from his desk and wander down from the hall to find a pencil. Provide modeless feedback. Feedback of progress is one of the key elements of flow. One egregious way done on the desktop is to pop up a dialog box. This technique is modal. It puts the application into a special state that must be dealt with before it can return to its more normal state. So we need to provide the progress using modeless feedback. So the traditional way to do this is modal feedback. So it puts the application in a special state, or it transforms the application in a special state. This must be dealt with that will freeze the application or main screen and before the person can continue with the task. A better way to inform user is with modeless feedback. You don't need to lock the state, it just show you instinctively. That allows you to provide the flow that has this compound effect or compound momentum that allows you to create more complex tasks with few. Feedback is modeless whenever information for users is built into the structure of the interface and doesn't stop the normal flow of activities and interaction. In Microsoft Word 2010, shown in figure 11.4, so here you see the word count, right? You can see what pages you are in. Sorry, here 7 out of 10. What section you are in, and how many pages are in the current document, and what position your cursor is in modestly. So you see here, you can just have to look at the left navigation pane and status bar at the bottom of the screen. You just need to left navigation pane to see what section and how many pages in the current document and the position of the cursor. You just need to go to check the left navigation pane and the status bar at the bottom of the screen. So use the status bar that is synonymous to the navigation bar we've discussed in the mobile before. You don't have to go out of your way to ask for that information. So you don't have to go out of your way or go to the next window. Application can use the edges of the display screen to show users information about activity in the main work area. So these edges could be used to provide activity and rich modeless feedback. Many drawing applications such as Adobe Photoshop already provide ruler guides, thumbnail maps, so you can also use thumbnail to say what part of the picture you are on this video, and other modeless feedback in the periphery of their windows. So again, periphery, which provides the highest cognitive navigational energy. In Word 2010, Microsoft lets you see what page you are on, the number of total pages, and the number of words in the documents displayed modelessly on the lower left. So these are actually modeless window, though it's showing the status bar. In the document displayed modelessly on the lower left edge on the window. Clicking on the word count opens the word count dialog. So if you click that, it will provide this dialog, which provides the pages, word, characters with no spaces, character with spaces, paragraph, lines, and then include notes and end notes. So that's the statistics, which provide more detailed information. Another good example is the iOS Notification Center, which displays a brief heads up alert when an app that is currently active on the screen has an important event to report. So I know you see that notification on your phone, such as an incoming appointment. The message stays at the top of the screen for a few seconds and then disappear. So it stays at the top and then disappear. And tapping it while it displayed takes you to the notifying app, which is great. It avoids the distraction of occupying the whole screen. So those notification is kind of modeless dialogue or modeless feedback as well. That allows us to do more with less screen real estate. Jet fighters have a heads-up display or HUD that superimpose the readings of critical information on the forward view of the cockpit windscreen. So the window where the pilot is looking, there's a heads-up display that superimposes the readings of their critical information. The pilot doesn't even have to use peripheral vision or like look left or right. Another way, she can read vital gauges while keeping her eyes on the opposing fighter or the you know opposing fighter of the jet, since it's a fighter jet designed for the probable but anticipate the possible. One of the most potent methods for better orchestrating your user interfaces is segregating the possible from the probable. So here, Microsoft Word, do you want to save the changes you made to chapter 9? Yes, no, cancel. So these are one of the confusion for the probable and the possible, because most of the time, though sometimes the user could choose the not save, but it's like sometimes the user could manually do that in the menu instead of having to ask that every time or 99% of the time. Developers are judged by their ability to create software that handles the many possible but improbable conditions that crop up inside complex logical systems. So because the developer are paid to do this, they think that providing this edge cases will be better for user as well. That this doesn't mean, however, that they should render that readiness to handle offbeat possibilities directly into a user interface. So this sort of thing runs counter to users' expectation and interrupts their flow by asking them to accommodate the possibility instead of running on the probability. Their action dialogues, controls, and options that are used 100 times a day should not sit side by side with dialogues, because that's your most common controls. And options that are used once a year or never. So it's only used once a year, those dialog box contextual information. The old Windows 3.0 file manager took great pains to report the exact number of bytes used by files on the disk. Did this precision help us understand if we needed to clear space on disk? Wouldn't a visual representation that showed disk usage in proportional manner be more meaningful? Luckily, luckily, Windows employs bar and pie charts to indicate disk usage. What we really need to know is whether the disk is getting full or whether we can add a new 20 megabytes application and still have sufficient working room. So these raw numbers, precise as they are, do little help to make us a sense of the facts and pull us out of flow as we try and figure out what's really happening. So these texts that perpetuates to help us are actually distracting us because it doesn't really help us on context. Now, visual information design expert Edward says that quantitative presentation should answer the question compared to what. Knowing precisely how many bytes are free on your hard disk is less useful than knowing that it's 22% of the disk total capacity. So you need to provide context compared to what, because those especially for those numbers and then text, it could provide a command line infinite options. Another tough dictum is show data visually rather than simply telling about it textually or numerically. Though text and numerical are still important, you should show this visually for the visual brain to satisfy. The meaning of the information could be shown visually. The numbers would merely add support. Today, this is exactly what is shown in Windows Explorer. Unfortunately, this is useful info is shown in only one place, rather than as persistent status indicator at the bottom of all Explorer windows. So it's only shown in one place instead of all the Explorer windows. So Windows Explorer, it's not File Manager, it's Windows Explorer. It's not Edge as well. I don't think Windows Explorer is still. What is that Windows Explorer? Is this the Windows Explorer? I don't know now. Yeah, but let just be that for Windows Explorer, let's just imagine that it provides that disk total capacity along with the number like this. Yeah, I think this is this. That's the Windows Explorer. I don't think you're seeing my screen though. Yeah, you're not seeing. So 298 gig free of 476 gig. Yeah, they learned their lesson. So reflect object and application status. So when someone is unoccupied, he looks unoccupied. His body is open and moving. His eyes are willing to make contact. People not only expect this kind of subtle feedback from each other, they also depend on it to maintain social order. So here, Baxter is a two-armed industrial robot to work alongside humans in light manufacturing production line. It communicates status using facial expression. So when the product is engaged from significant internal action like performing a complex calculation, and connecting to a database, it should be obvious to us that it won't be quite as responsive as usual. So we should provide the status indicator. Like here, if our body is open and moving, we're willing to make contract. So this lets the user plan their next step accordingly. Similarly, the status of user interface objects should be apparent to users. Most email applications do a good job of making it obvious which messages have not been read and which have been responded to or forwarded. We should also provide those pliant or visual feedback to the user. Wouldn't it be great if when you're looking at events in the day or weeks of Microsoft Outlook or Google Calendar, you could tell how many people had agreed to attend and how many hadn't responded yet, either right, inline, or via tooltip. So using tooltip, you can see that without drilling down into details. So those are kind of instinctive visual feedback that we want to provide. Those like instinct, intuition, or it could be idioms if the user learns this kind of status indicator. This kind of communication is best done using rich modeless feedback as discussed in the previous video. So we can provide a rich modeless feedback just like in email. You see exactly what email you've read and not read. So avoids unnecessary reporting. Some applications are quick to keep users apprised of the details of their progress, even though the user has no idea what to make of this information. Even though it is not related to the context, applications pop up notification telling us that connection have been made, that records have been posted, that users have logged on, that transactions were recorded, that data has been transferred, and other useless factoids. To software engineers, these messages are equivalent to the humming of the machinery. They indicate that all is well. In fact, they probably were used while debugging the application. To a normal person, however, these reports can feel like eerie lights beyond the horizon, screams in the night, or unattended objects flying about the room. For users, it is disconcentrating and distracting to know all the details of what is happening under normal conditions. So if it's a normal condition, it is distracting to see all of this notification. Non-technical people may be alarmed to hear that database has been modified. For example, it is better for the application to simply do what has to be done. Issue reassuring and modest visual or auditory feedback when all is well, instead of this notification dialog box, which we also discussed in the previous video, and not burden users with the trivia of how it was accomplished in the back end or imposing the implementation rule. It is important that we not stop proceeding to report normalcy. If it's normal, don't provide dialogue. Instead, provide rich modulus feedback. By the same token, don't stop the proceeding and bother the user with minor problems. If the application is having trouble creating a connection to a server, don't put up a dialog box to report it. Instead, build a status indicator like the one we've discussed into the application so that problem is clear to the interested user. But is unobtrusive to someone who is busy elsewhere. If you're doing something else, those pop-up dialog box could be distracting, but a status indicator could be useful for curious of what is happening on the background. Design principle: don't use dialogues to report normalcy. So avoid blank states. The key to orchestrating a user interaction is to take a goal-directed approach. Again, you need to know the goal, because that's where the basic will came from. You must ask yourself where a particular interaction moves a person effectively. So to be able to implement this, you need to know the probability as well of the action of the customer toward this goal. Most people would rather see the application take a good enough first step and then manually tweak it to what is desired. This way, the application moves the person closer to his goal. How many applications have you seen that start by asking a bunch of questions up front, or that punt every decision to a litany of user options? But normal people rather than expert users. So how many applications have you seen that start by asking a bunch of questions, right? Or that put every decisions to the user instead of them having the default settings option that will probably be used by those people that they identified in the user goal-oriented research. So it just seems more of a lack of proper research with the design team rather than the implementator, right? So, or the one who implemented. But normal people, rather than expert users, sometimes are incapable of or uncomfortable with explaining what they want to do to an interactive product, especially in advance. So they are incapable. So one of the facts or user facts to this interface is that users are incapable of what they want to do in the product in advance. So they would much rather see what the application thinks is right and then manipulate that to make it exactly right. So they can just revert this if that default setting does not fit their use case. So in most cases, your application can make a fairly correct assumption based on the designer's estimation, past experiences with the user, or by reference to most other users. For example, when you create a new document in PowerPoint on the PC, the application creates a blank document with preset attributes rather than opening a dialog that asks you to specify every detail. Opening Graphol on the Mac does a less adequate job, asking you to choose the base style for a new presentation each time you create one. Both applications could do better by remembering frequently and recently used styles or templates and making those the defaults for new documents. Design principle asks for forgiveness, not permission. For most users, a blank state is a difficult starting point. It is much easier to begin where someone else has left off. They can easily fine-tune an approximation provided by the application into precisely what he wants, with less risk of exposure and mental effort than he would have by drafting it from nothing. So it's a difficult starting point because the user will provide a lot of cognitive load just by using the basic or common task. It's much easier to begin where someone has left off. They can easily fine-tune an application provided by the application into precisely what he wants with less risk of exposure and mental effort that he would have done by drafting from nothing, as we discussed in chapter 8. Endowing your application with a good memory or making it smart is the best way to accomplish it. So you need to remember those, and then providing undo if like the one provided in the previous video, because it helps the user or the usability. Differentiate between command and configuration. Another problem crops up frequently when user invokes functions with many parameters. If you ask an application to perform a function by itself, the application should simply do it using a reasonable default or its last configuration. So let me just stop a moment. I'll just grab something. Alright, so we'll continue. Differentiating between command and configuration. So it's about like differentiating the functions, kind of like in the modal chapter that we've discussed. The tools on that palette should be the most common function. So you need to know the user goals and what is the functions related to their harmonious interaction flow, and then you need to provide a configuration for that functions. But you need to let just discuss in the previous video, uh, be careful in providing those model dialog or configuration for each function, so otherwise you risk the creating every function simple functions with the configuration. So another problem crops up frequently whenever users invoke functions with many parameters. If you ask an application to perform a function by itself, the application should simply do it using a reasonable default or its last configuration. So it is related to the blank states that we have discussed. So to express different or more precise demands to the application, you would launch the configuration interface for that function. So more precise demands or more precision requires you to launch this model box configuration for that function. For example, when you ask many applications to print a document, they respond by launching complex dialog box demanding that you specify how many copies to print, whatever the paper orientation is, what paper feeder to use, what margins to set, whether the output should be in monochrome or color. So it asks all of this: how many copies, what paper orientation was, what paper feeder to use, what margins to set, whether the output should be in monochrome or color. So what's the color, what scale at which to print, whether to use PostScript fonts or native fonts, whether to print the current page. It could have been done with the normal font like sans serif or Times New Roman. So whether to print the current page as well, or the current selection, or the entire document. So the default here is the entire document, right? And whether to print to a file, and if so, what to name that file. So would you want to print that as well as to create a file, which in the default you would really want a copy of that file? So all these options are useful, but all we want is to print the document, and that is all we thought we asked for. So more reasonable designs have one command to print, another command for print setup, like this, like that small small print icon. The print command issues a dialog, but just goes ahead and prints. So more reasonable designs have one command to print and another command for print setup. So there's a separate dialog box, and that's another command to launch that model dialog. So the print command issues a dialog, but just goes ahead and prints. So it issues a dialog. It's still a dialog, but it just prints it using either previous settings or standard settings. So it used the default. Unfortunately, it's very small and hidden by default. So the print setup function offer all those choices about paper and copies and fonts. So the print setup allows us to choose all those configuration. The quick print control in the Microsoft Word offers immediate printing without a dialog box. So this is perfect for many people, but for those with multiple printers or printers on a network, therefore the print menu or print setup is more appropriate. It may offer too little information just for that little print dialog. The user may want to see which printer is selected before he either clicks the control so if you're using a network, you want to see which printer is selected before you click the control or summon a dialog to change it first. Whether it's there's a configuration on that location of the printer, this is a good candidate for some simple modeless output placed on toolbar or status bar. So if the user wants to see which printer it is, you can provide this modeless feedback on the toolbar, so it doesn't need to launch this dialog box. Now it is currently provided the control in the controls tooltip in Windows version, which is good, but the feedback could be better still. Word's print setup user interface, which also include the print button, is called print and is available as a menu item on the file tab of Word's ribbon control. So this print setup interface is called print. It's available here in file type in kind of like, I think this is like, so there's a print preview and there's a printing. When we print, what happens? So there's a launch dialog box that allows us to choose. So if he wants to configure it, but I'm thinking there's like a print button as well. Where is that? So that's on home. Where's that print? I don't know, maybe there's no print here because that's not really the usual way we do this note. We don't really usually print here, but in Word, let's see. If we go back home, there should be a print icon. File home. I'm currently finding the print in Word, but I'm not able to see it now. Maybe they removed that already. Here, quick print. So it is in a toolbar now, including save. So I was able to actually click the quick print, but it is in text rather than in this icon. So Word print setup user interface, which also include a print button, is called print and is available as a menu item on the file tab of a Word's ribbon control. So when we click the file and then click the print, it will show us the how many pages print on one side collated and to configure that. There's a big difference between configuring and invoking a function. The former or the configuring may include the latter, but the latter shouldn't include the former. Generally speaking, a user invokes a command 10 times for every one time he configures it. So that's 10 to 1. It is better to make the user ask explicitly for configuration one time in 10 than it is to make the user rejects the configuration interface 9 times in 10. So thus, most desktop applications have a reasonable rule of thumb. Put immediate access to functions and buttons in toolbars, and put access to function to configuration user interfaces in menus. So put immediate access to functions or when you say functions, the most common features that is used on buttons in toolbar, and put access to function configuration in user interfaces in menus, or in more hidden in the back of the application. So the configuration tools are better for learning and tinkering whereas the buttons provide immediate, simple action. So for a simple action, that's better. Hide ejector seat levers. So ejector seat levers have catastrophic results. Um, 1 minute, the pilot is safely ensconced in his jet, and the next he is stumbling end over end in the wild yonder while his jet goes on without him. The ejector seat is necessary for the pilot's safety, but a lot of design work has gone into ensuring it never gets fired inadvertently. Allowing an unsuspecting user to configure an application by changing permanent objects is comparable to firing the ejector seat by accident. Hide those ejector seat levers or the permanently object or changing permanent object. So a lot of design work has been done to avoid this getting pulled out, but it's all for the pilot safety. Just as a jet fighter needs an ejector seat lever, complex desktop applications need configuration facilities. Application must have ejector seat levers so that users can occasionally move persistent objects in the interface or dramatically, sometimes irreversibly, alter the application's function, behavior, or content. Sometimes you can irreversibly malfunction that system, kind of like an operating system or some app actually disturb the configuration. That's why sometimes it asks you to run as an administrator. So ejector seat levels comes into basic varieties. Those that cause a significant visual dislocation, large changes in layout of tools and work areas. This must be hidden in the application. And those that perform an irreversible action. So a dislocation, visual dislocation of large text and icons or tools, and irreversible action. So both of these actions should be hidden from inexperienced users. Of the two, the latter is varieties by far the most dangerous because you can reverse it. In the former, the user may be surprised and dismayed at what happens next, but you can at least back out of it with some work, kind of like in the voice interface in mobile phones, where you need to kind of navigate using some special actions if you activate the voice accessibility interface. In the latter case, she and her colleagues are like to be stuck with the consequences. So productive users are happy users, and customers with productive happy users are the goals of almost any digital product manufacturer. You don't want to pull this lever and make an irreversible action to make the user not use your application. So in the next chapter, we will discuss the exercise. So we've discussed that in the previous video, the exercise. So yeah, that will also help with the flow of our application. Just a moment, guys. I'll just charge my laptop. So we have discussed that in the previous video, the removal of excise because of the result of implementation model thinking on the user. Optimize for responsiveness but accommodate latency. So nothing is more disturbing to the user's sense of flow than staring at the screen, waiting for the computer to respond It's critical to design your interface so that they are sufficiently responsive. So you don't want your user um, to stare at the screen while waiting for the response. So it's critical to design your interfaces so that they are sufficiently responsive, so that the user know that the application acted from their inputs. All the lush visual style in the world won't impress anyone if the interface moves like molasses because the device is maxed out redrawing the screen. So you don't want this slow up. If your application executes potentially time-consuming task, make sure that it occasionally checks to see if someone is still out there, madly clicking the mouse and whimpering, no, I didn't mean to reorganize the entire database. That will take 4.3 million years. In a number of studies dating back to late 1960s, it's generally been found that users' perception of response times can be roughly categorized into several buckets. So here, up to 0.1 seconds, users perceive the system response as instantaneous. If it's 0.1 seconds, it's instantaneous. They feel that they are directly manipulating the user interface data. Up to about 1 second, user feels that the system is responsive. Users will likely notice a delay, but still small enough for their thought process to stay uninterrupted. Up to about 10 seconds, user clearly notice the system is slow and their mind is likely to wander, but they can keep up some amount of attention on the application. Providing a progress bar is critical here. After about 10 seconds, you will lose your user attention and they will wander off and get a cup of coffee or switch to a different application. Ideally, processes that take this long should be conducted offline or in the background. So it should be a daemonic application. Allowing you or daemonic functions or configuration allow users to continue with other work. In any case, status and progress should be clearly communicated, including estimated time remaining. A constant mechanism is also critical. So status and a visual modeless feedback, again, a progress bar is critical. Motion, timing, and transitions. So the first computing device to use motion and animated transition as core elements of the user experience was the Apple Macintosh. Mac windows sprung open from draggable up and foldable icons and collapsed back into them when closed. It sprung open from draggable up and then fold their icons and collapse back into them when closed. It provides motion, timing, and transition menus. Drop, open when click, and roll up again when the mouse button was released. The switcher facility in early Mac OS allows you to change the current open application. Switcher facility in early Mac OS, it allows you to change the current open application by clicking a control in the menu bar. So a switcher facility in early Mac OS actually allow you to change the current open application by clicking a control in the menu bar. So by clicking one of the controls in the menu bar, it allows you to change the current open application. So let's provide a motion, timing, and transition. The control causes the current app screen to slide horizontally out of view to the left. So it's like an animation. Another open app screen lead in from the right like a carousel. Amusingly, this carousel-like app transition has reappeared on the iPad as an optional 4-finger left or right swipe gestures, also in the mobile app, right? In the later versions of Mac OS and Windows, more animated transitions were added. So this operating system are actually the ones that adding it, as well as the iOS and Android. Dialogues no longer simply appeared. They slid or pop into place. So those dialogue that traditionally are windows or boxes are now slid or pop into place. Expandable drawers, palette, and panels become common idioms, especially in professional software. However, it was not until the advent of the iPhone that the use of the motion and animated transitions become an integral and critical part of the digital product experience. Because in mobile, it's more immersive. In concert with multi-touch gestures, animated transitions allow mobile apps to appear so responsive and immersive that you almost forget what is being flicked, pinched, uh, twirled, and swiped on screen is really just pixel, providing an illusion of physicality. So this is also related on this optimized for responsiveness. So motion is a powerful mechanism for expressing and illustrating the relationship between objects. So that motion actually just provides us a relationship between objects. This mechanism has been particularly successful on mobile devices where the form factor limits what can be shown on screen. Animated transition help user create a strong mental model of what is presented in one view is related to what was presented in the previous. So it allows us to go from past to present to future. It's often used to good effect on the web as well, helping create a spatial aspect to navigation and state transition. So it's usually used for state transitions or the modes in this tool. Although it's tempting to do otherwise, motion and animation must always be used sparingly and judiciously. Not only is an abundance of motion potentially confusing and irritating, but it can also make some people ill. This fact was reported after the release of Apple iOS 7, possibly due to its new and somewhat overzealous parallax and app zoom out and zoom in animations. So the overarching goal of motion and animated transition in interaction should be to support and enhance the user state of flow and the context we want to achieve. As Dan Saffer discussed in excellent book, Micro Interaction, animation and transition should help achieve the following. Focus user attention in the appropriate place or context, show relationship between objects and their actions to provide context, maintain context during transition between views or object states to provide those states and modes and not interrupt flow, provide the perception of progress or activity such as through progress bars and spinners to avoid the navigational exercise, create a virtual space that help guide user from state to state and function to function. Encourage immersion and further engagement. To provide flow, create virtual space that help guide user from state to state and function to function that allows them to see the transition and provides them feedback, kind of like providing that rich models feedback with our instinct. So furthermore, designers should strive for these qualities when creating interactions involving motions and animation. Short, sweet, and responsive, animation should not slow down interactions and thus interrupt flow and context. They should last only as long as it takes to accomplish one or more goals just listed, and in any case less than 1 second to retain a feeling of responsiveness. Simple, meaningful, and appropriate. In iOS 7, Apple changed how you kill a running app. Previously, you tap and hold the app icon in the multitasking tray, waited for an X icon to appear on it, tap it, and then press the home button to exit a mode. This was almost the same action you took to delete the app from the product. So now you flick a representation of the app last screen away from you, causing it to scoot off the top of the screen. So this is much simpler and more satisfying, and it is appropriate to the function it triggers. Sadly, it is equally undiscoverable as shown in 11.10. So in iOS, to kill an app, you flick a representation of the app's last screen away from you, like swapping it up. This is much simpler and more satisfying than old method, tapping and holding the app and put it into a delete mode, like uninstalling it. So natural and smooth animated transition, especially those providing feedback to gestural interfaces. So it should be natural and smooth, especially for touchscreen. It should feel almost like real physical interactions, mimicking, if not modeling, motion attributes such as inertia, elasticity, and gravity. So motion is successful when it has rhythmic quality, in which the timing helps the user anticipate what will be shown next. That's why it only provides 0.1 seconds, etc. Changes in timing can be used to cue users about changes in context, state, or mode. This visual feedback, kind of like an instinct, can also be reinforced by the use of sounds. Sounds can help direct user interactions. The top of a button in iOS express the effect of user interaction. The clicking as the selection changes in the PlayStation 3 main horizontal menu, or reinforce a transition, a whoosh that accompanies a swipe gesture. The ideal of effortlessness. So creating a successful product requires more than delivering useful functionality. You must also consider how different functional elements are orchestrated to enable users to achieve a sense of flow as they go about their business. The best user interface often don't leave users in awe of their beauty, but rather are hardly even noticed because they can be used effortlessly. So if you're helping your user achieve their goals magically, they shouldn't notice you, because the bad writing, kind of like in bad writing, if your app has been noticed, it means it's not doing their job, creating the state of flow to the user to help them more productive or achieve their goal. If you are achieving their not like disturbing your neighbors and helping them achieve their goal or this productive focus, then you won't be an insult to them. So you could do this to help your users, not make sure to see what's important to them, such as your, respecting your neighbors, etc. So understanding the importance of flow, orchestrating your interface to maximize it, and making judicious use of motion and transition to ease the user from one state or mode to another can give your apps the aura of effortlessness that helps make them seek to work like magic. So orchestrating your app to achieve this flow, and then with regards to their context and achieving flow, will provide it the aura of effortlessness that make them seem to work like magic.